My name is Tyrone Shu, and this is my lab report for Intro to Physics 2212. This lab is based on the charge tapes experiment. The purpose of this lab experiment is to conduct an experiment using charged piece of tapes to determine approximately how much excess charge is on one piece of charged clear tape. The main physical principle of this lab is using clear tapes to modify charges by assuming that each piece of tape had equal distributed charge in order to apply Coulomb's law using Newton's second law, which is force equals mass times acceleration. In results, we got from the lab is the two charged pieces of tape repulsed from each other, and the charge on one piece of tape is 1.24564 times 10 to the negative 8 coulombs. And the deficiency of electron of one piece of tape is about negative 4.15213 times 10 to the negative 9. The physical ideas in this lab are Coulomb's law, which is basically described the electric force between two charged particles a certain distance apart with a certain charge. Each electric force field is the force created by a charged particles. The electric field can be thought of as the force of a small positive test charge would feel as a certain location due to a charged particles, and hence the units of the electric fields are newtons per coulombs. Force due to the gravity is an attractive force, for light to simplify for use near the Earth's surface. And last key is just knowing how to use the manipulate vectors. We assume that air resistance is negligible, and we're treating a long piece of tape as though it was a point charge with all the charge concentrated at the center of the long tape. We assume that each U tape had about the same amount of the charge evenly distributed on the length of the tape, and the models are each piece of tape were used to model a point charge. Regards to the experiment, we chose the system to be tape A and tape B, and the surrounding to be everything else in the room. So for the initial conditions, it was two pieces of approximately neutral tape, also being about equal in length, and a third piece of neutral tape, which was stuck down on my desk. So for the detail for the experiment, tape B was stuck to the tape on the desk and ripped off quickly in order to charge it, either leaving behind electrons or gaining more electrons. Through the process, the tape was then hung in near several objects. To determine its charge, it was finally placed above the other piece of similarly charged tape, tape A, until the portion of it floated and the distance was measured between the tape calculated tape B's charge. Regards to our data, I was able to determine these measurements for the tape. And using the measurements, I determined the force of gravity on the tape, which is about 0.00187 newtons. As you can see, tape B was the rest sphere, while tape A is the y sphere. The yellow arrow represents the electric force, while the green arrow represents the gravitational force. And as you can see, the forces on tape B are bound. Regards to some of the discrepancies between the models and the actual experiment, one is that obviously the piece of tapes were not actually point charge, but we're just used model as such, as so may be some inconsistencies due to that and the charges on each tape are likely not exactly equal as we assume in the calculation. Some potential source of errors were that each tape were not equally charged, meaning that Q may not have been equal for each piece of tape. Regards to these questions, the observation that I made would have remained exactly the same as even though the charge conventions have switched in these scenarios, it would still interact the same with like charge repelling and opposite charge attracting, so that charged piece of tapes would still, even though they would have been negative under the charge convention, they would still have repelled each other and they still would have been attracted to now positive pin. With regards to some of the conclusions, that I reached though the lab, I found that everyday object can be used to modify point charge and observe electric interactions by charging them. Newton's laws of force can play an important role in determining the individual qualities associated with an object, such as objects can easily and accidentally be slightly charged through touch alone and electrical force, and fields are an important part of our world that account for many physical interactions that occur. Thank you for watching.